Hello and welcome to this podcast from the BBC World Service. Please let us know what you think and tell other people about us on social media. Podcasts from the BBC World Service are supported by advertising.
Hi, this is Benjamin from the UK true crime podcast They Walk Among Us. Brought to you by AMC Networks, Shudder is a premium streaming experience that provides a multi-sensory dive into fantastical worlds, offering the very best of old and new horror. Discover films and series that covers the entire horror spectrum, including highly anticipated new releases like The Boy Behind the Door and Psycho Gorman, to giants of the horror genre like the Texas Chainsaw Massacre and Halloween. What's more, you can watch one of my all-time favourite films, Mandy, a spiralling, surreal, bloody journey of revenge with visuals that are simply mind-blowing. Exceptional originals, movies, TV series and live events, there's always something new and unexpected for Shudder members to experience. Sign up at shudder.com.
Thank you for downloading the Science Hour from the BBC World Service with me, Roland Pease. In half an hour, crowd science immerses itself in some virtual violence.
Okay, Alex, I'm scared. Are they behind me?
Gets the adrenaline going, but does it alter player psychology? Answers on crowd science later in the podcast. Before that, on Science in Action, we hear why backchat may have been good for human evolution. We look through the looking glass into a world of mirror biology.
Ting Zhu and his team stored some of their mirror DNA in some local pond water, and they found that they could amplify it and sequence it after a year. No problem at all. Whereas if you used normal DNA, it had gone off.
We hear what genetics tells us about the out-of-Africa picture of human origins and the first Middle Eastern civilizations. First, the idea of scientists studying record-shattering climate extremes seems, to be blunt, rather shouty. Yes, we expect and have seen temperature records rising, but record-shattering? It's the language of newspaper headlines. Yet, last month we did see temperatures in the western US and Canada smash previous records by over 4 degrees. And that's just what we should expect, according to a study prepared much earlier, but published coincidentally only a few days later. A hallmark of rapid climate change, it says, will be an accelerating number of record-shattering and socially disruptive events. One of the authors, Eric Fisher, suggested I contrast the situation with athletics, where ever better training has just about squeezed out all the increases possible in human performance.
Say for long jumping, high jumping, some of the world records date decades back, and if they're currently broken at all, they're usually only broken by 1-2 centimeters. So the longer we measure, the more people try something, the harder it gets to actually break a record.
That's if everything else stays the same.
Exactly. This is assuming that we have no climate change, but what we're currently witnessing is quite the opposite. Suddenly, we don't only see more record events, but we also see those records broken by a very large margin, and this is a very clear indication that something is going on.
I mean, what was the chance that your paper should come out within weeks of this extraordinary event in the Western USA and Canada, where the records were smashed by 5 degrees?
Well, that was a coincidence, obviously, but on the other hand, we've actually seen similar events over the recent years, quite many of them. If we think about the Siberian heat anomaly, it was a longer-term event in 2020, but it was also, if you look at the temperature up to the event, it was way beyond anything that has been observed before. Then the Australians may remember the 2018-2019, what they call the angriest summer. Again, another event. Different timescales, but way beyond anything previously observed, and 2003 and 2010 heat waves that are very well explored are again events. So it is a coincidence, but actually we've seen quite a lot of these events occurring over recent years and decades.
And your point is that it's the speed of climate change at the moment that means that I shouldn't be saying not another year with a record event. In a sense, I should be expecting at least every few years to see something absolutely shattering happen.
That's correct. So for the traditional definition of a heat wave as an anomaly versus a baseline, or as a deviation from a baseline, we have very good scientific evidence that primarily it's the amount of global warming that matters. Independent when we get to 1.5 or 2 degrees, we're going to see more frequent heat waves occurring. But for this type of events, for these record shattering, I call them, it's really the pace, the speed of warming that matters here. And it's interesting consequences then if we basically were able to limit the warming, say, to 1.5, 2 degree, or any other level of global warming. We would still see substantially more events to occur, but after a couple of decades after stabilization, these type of what we call record shattering extremes should become less frequent. It's important to remember
in a
that
sense, it's this idea of the new normal at the moment. We'll never get stopping at a new normal because it's always changing year on year.
That's correct. So if you think about a 50-year heat wave or a 100-year heat wave, if it would occur, if the same weather patterns occur 50 or 100 years later, it will be occurring in a substantially warmer climate, and it will break the previous record by a very large margin if the warming had been occurring very rapidly in between these two events.
Am I right? Also, I mean, you sort of model some of these heat wave events in your paper. And as I understand it, one of the mechanisms you're saying is that you're much more likely to get the coincidences of different things coming together to give that kind of, for example, what we just saw in Western USA, extreme dryness and extreme heat and pressure all at the same time.
Yes, so we specifically looked at the processes that cause these type of events in our climate models. Because honestly, when I first saw one of these events in the model, I thought it must be an error. So it was so way beyond anything that had previously occurred in that specific climate model simulation. So we went back to this climate model simulation and said, well, let's have a closer look what's going on, whether suddenly other processes are coming here in play. And what we found is actually that is primarily the well-known drivers of these type of heat waves. So we have a anticyclone, so a high-pressure system that is persistent there for a week or two. Plus, in this specific event, we have a very dry spring up to the actual event when the onset of this particular event. We know that this drying is occurring in many places. So in another way, yes, that's correct. We should be expecting to see a higher chance of these dry conditions plus this very high pressure system to co-occur. And then in addition to that, we have the whole thing occurring in a warmer climate. So again, if we have the same weather pattern occurring in a substantially warmer climate, we would expect the resulting heat wave anomaly to be substantially more pronounced.
The other thing you have in your paper is a map sort of showing where these kinds of events are most likely to happen in the future. And it seems to me it's interesting. It's very focused on certain regions of the world. And to be frank, these are, a lot of them, politically very important regions when it comes to the negotiations over climate change.
So that's correct, yeah. And so we see a lot of these areas actually scattered along the northern mid-latitudinal land regions. But in our paper, we specifically highlight an area that may actually be one of the few that hasn't seen much of a trend. And this is the eastern US and the US Midwest, where the hottest summer often still date back from the 1930s. And this is often highlighted as some evidence that things are not changing everywhere. But we argue that we need to be very cautious because these areas may have simply by chance haven't had the weather pattern recently that they've seen in the 1930s that caused these very famous so-called Dust Bowl drought and heat waves. And we argue that while there hasn't been much of a trend, basically this may be a slightly misleading and people are actually probably not very well prepared if the same weather patterns would occur today, again, in a substantially warmer climate. We would expect to see what we call record shattering, so events that go way beyond what has been previously observed. And it's maybe actually often these places that haven't experienced such a trend that are not very well prepared.
Eric Fisher of the Federal Institute of Technology in Zurich, who took some precious minutes out of negotiations over the next international climate assessment due on Monday to talk to Science in Action. His study, which was published in Nature Climate Change, has already generated a lot of comment from experts on social media and may become a bit of a landmark in climate literature. Social media are notoriously where strong voices strive to outshout each other, to seek dominance. The vehemence is often highlighted as showing what's wrong with human relations. But in the light of a new, large study on communications and hierarchy across a large range of our ape and monkey relatives, perhaps we should look on the noise more favourably. Like us, they live socially in groups, and there are leaders. But the more tolerant ones are also the more communicative ones. In species with despotic leaders, order seems to be maintained with more menacing silence. Lead author Katie Slocum invoked an analogue in children's literature.
A really nice analogy is, if we take Harry Potter, is that, two professors are in charge of their students. They are dominant to their students. We've got Professor Dumbledore and we've got Professor Snape. Now, Professor Dumbledore would be a really good example of a tolerant leader, a tolerant, dominant individual, because he, allows transgressions of those rules. He allows the students to push the boundaries a little bit. Whereas Professor Snape would be on the other end of the spectrum. He's very strict, so he would be a despotic management style. He is very strict. There is no breaking of the rules with him. And you get the impression that if he could use violence to enforce that against the students, he would.
And their vocal styles match what you're seeing in these primate groups, are they?
Dumbledore tends to be a bit more chatty than Snape does. But what was interesting is we also looked at the subordinate individuals, because at the beginning we thought that it actually might work two ways. That, okay, the dominant individuals might have more need to negotiate and communicate more in a more tolerant society, but also maybe the subordinates might be fearful to communicate a lot when they're within a strict despotic hierarchy. So it might be kind of inhibiting communication in those subordinate individuals, but actually we found no evidence for that. So the selection pressure here really does seem to be on the dominant individuals rather than the subordinate individuals. So if we go back to the Harry Potter example, the students chat kind of an equal amount in Dumbledore's classes and in Snape's classes, but what the difference is in the ones at the top. So it's that Dumbledore is chattier than Snape.
I was wondering whether part of what you're looking at is the nature of these communications, the nature of these vocalizations. For example, whether they're loud, or how much variety there is. Is that related to any of this?
So the other measure that we took was not just how often they vocalise, but we also then looked in the literature to see how many different calls do you make. So we looked at their repertoire size and saw if that actually differed depending on whether you're tolerant or despotic. And we didn't find that for the overall repertoire, so the overall types of sounds that they make, but we did find it for a kind of a subset of those calls, which are the ones which manage the hierarchy. So calls that are given to assert dominance or to give submission to a more dominant individual, those are larger in the more despotic species, so the stricter species. And I guess that makes sense because they've got a greater need to manage those relationships accurately, because the consequences of transgressing in those stricter hierarchies is much worse. So it's really interesting that we see that tolerance on a kind of individual level is promoting more communication in the dominant individuals, but on a kind of evolved communication level, on their kind of vocal repertoire, we're seeing that actually if you are stricter and you're more despotic, you have slightly more calls to kind of negotiate those interactions with.
I mean, I just wonder what sort of calls you're saying that one might be, "Oi, leave that other chimp alone" or something, or I don't know. It's you're saying that they have very specific calls for very specific transgressions. Maybe what's going on.
Yes, so for instance, in the chimpanzees, they have a pant grunt vocalization, which is a that they give, and that's only ever given from subordinates up to dominance. So it's a formal kind of signal of submission saying, yes, please go ahead, you are ahead of me, I acknowledge my subordination to you. So it's those kind of signals that we see more in the more despotic species. We see a greater variety of signals that communicate those kind of messages.
Even though there are fewer overall, this is quite an interesting sort of sociology going on here.
Yeah, so they have, so in the overall repertoire, we didn't find any difference, but in those calls that are there to manage those dominant relationships, there are more if you're stricter. Yeah, that's right.
I mean, it's really interesting if you're looking at some kind of universal rule, because it seems to me that you're looking at so many different species with so many other biological and pressures and geographical pressures on them, that the idea that there is an overall trend, at least, is quite surprising.
Yeah, and I think it probably shows that it's a relatively strong signal, and probably had quite a strong influence. And looking up to humans, we know that humans in our recent evolutionary past were a highly tolerant species. And so kind of, again, this study is really interesting in terms of looking now to try and see if we can work out what influence possibly, a greater tolerance within humans might have had in the role in evolution of language.
I mean, it's a fascinating thought, because language and the transmission of cultural knowledge, as the anthropologists talk about, is incredibly important, I presume, to the human success as a species. Yes. The idea that we got there because actually we did talk and rather than just shout, it seems to be quite an interesting one.
Yes, and there are lots of theories saying that cooperation and language likely co-evolved, and this would be a really nice example of how if you are more tolerant and that kind of promotes more cooperation, then that kind of relaxes the constraints on communication, and therefore communication happens more, and then probably with time it becomes more complex.
York University psychologist and primatologist Katie Slocum, who managed to keep order among her 63 co-authors with a minimum of shouting and maximum talking, she promised me. Perhaps a little social magic. The study was published by the Royal Society earlier this week. And we move slickly from the shadow world of Harry Potter to the mirror world of another children's classic, Through the Looking Glass. Around a decade before Lewis Carroll imagined Alice's topsy-turvy mirror world, biologist Louis Pasteur reflected on the differences we might see if biology was seen through a mirror. He had already noticed that mirror image biomolecules don't match their originals any more than a right hand can fit a left-hand glove. Who could foresee the organisation of living things if cellulose, right as it is, became left? If the albumin of the blood, now left, became right? These are mysteries which furnish much work for the future. Much work indeed, and it's been undertaken by Chinese synthetic biologist Ting Zhu, who has succeeded in manufacturing a long thread of mirror DNA with the help of a mirror enzyme, a so-called polymerase, which he had to first construct. Science writer Mark Peplow has long been a fan of Ting's effort and thinks this new work is a significant step towards mirror life.
Yeah, it's a fascinating and weird and frankly heroic effort. Ting Zhu has previously been able to make small mirror polymerase enzymes to create and copy mirror DNA, but the smaller ones have been not very active, they make a lot of errors. So this new one, this is really the bee's knees. It's stable, it's efficient, it's very accurate, and he's made it using, it's called PFU DNA polymerase, and it's got 775 amino acid building blocks in it. He reckons it's not only the biggest mirror protein to be made by chemical methods, it's the largest functional protein of any kind to be synthesized in this way, and he's done it by basically making a few, I won't call them cheats, but they're judicious changes to the natural sequence of amino acids that you find in this polymerase in nature to make it easier to put together And basically they start by making small chunks, they stick those smaller chunks together into medium-sized chunks and so on, and they end up with two large fragments that eventually neatly fit together to make this working mirror polymerase.
You talk about it being built up by the smaller chunks and bigger chunks. Presumably even the building blocks, the amino acids that are the very starting point of a protein, even these have to be presumably mirror images of the ones you'd normally find?
Yeah, that's right. So life uses mostly, not exclusively, but mostly amino acids with an L-handedness to them. So these mirror proteins have to be built up using their reflection, D amino acids, which you can buy. You can buy them off the shelf. They are available. But yeah, they're different building blocks than you get inside the proteins in you and me.
It all starts to sound a bit to me like trying to, assemble a Swiss watch, but doing it behind your back and with your left hand instead of your right hand. You're making it as difficult. He's making it as difficult as he can.
Yeah, that's right. But the outcome of this is that they've used this polymerase, it works, and they've used it to create an entire mirror gene. Now remember, a gene is a bit of DNA that actually does something useful. It codes for a particular stretch of RNA, which can, in some cases, can then be used to make a protein. In this case, the bit of mirror RNA that this gene codes for is actually a core component of a molecular machine called the ribosome. Only in this case, it's the mirror version of the ribosome. Now, the ribosome in your cell is the thing that builds proteins. So if they can get an entire mirror ribosome working, they can finally dispense with all this faffing around with chemical synthesis, incredibly laborious, and they can make a mirror ribosome that will do all this itself much more efficiently than they've been able to.
I mean, down the road, I think that the ideas that could be played with are absolutely mind-boggling, but they got some pretty practical applications in this current paper, haven't they?
Yeah, they have. And it's kind of to show off that this is not just an esoteric piece of work. They can actually do useful things with it. And in this paper, they use mirror DNA to store information. Just as a proof of principle, they take a paragraph of text that was written by Louis Pasteur, the famous scientist, back in 1860, in which he's actually speculating on the possibility of a mirror image world of biology. So, well over a century ago that Pasteur was thinking of this. So they developed this code where each letter of the text is represented by 3 of the bases in DNA, the little bit of information carrying letters that you get along the DNA backbone. And they use their mirror polymerase to make these strands, and then they use another mirror polymerase to actually read the text, so it proves that you can reliably write and read mirror DNA sequences that hold a passage of text. Now, interestingly, they also create this encryption system where they can mix both left-handed and right-handed DNA, and these different sections act as a code key that flag specific letters in Pasteur's paragraph. So effectively, that it's like these sections of left and right-handed DNA that are the key. They might contain numbers like you need to go to the 4th letter, the 8th letter, and the 19th letter. And eventually, they point to letters that spell out a message. Now, if you just sequence this key using natural polymerase, reading the normal version of DNA, it spells out a false message. It spells out the word error. Only using mirror polymerase acting on the mirror DNA can you get the true message, which in this case is mirror.
It's that bit where you say, turn to page 7 and look at the 14th word, and page 9 and look at the 20th word, but here it's with letters.
Yeah, that's right. Now, other scientists have been able to encode much larger amounts of text in DNA. This is very much a proof of principle, but interestingly, it shows that mirror DNA might offer at least one advantage over storing information in normal DNA, because mirror DNA, because it's unnatural, it tends to resist degradation in the environment. So Ting Zhu and his team stored some of their mirror DNA in some local pond water, and they found that they could amplify it and sequence it after a year, no problem at all. Whereas if you used normal DNA, it had gone off in a day and they just couldn't read the message accurately.
science journalist Mark Peplow, and you can speculate endlessly, Latin speculum meaning mirror, where this work of Tingzhu's might lead. Finally, one of the benefits of science's ability to read normal DNA has been to compare human genomes from across the globe, for example in the Human Genome Diversity Project, for what they reveal about both our health and our past. But sequences from the Middle East have been sadly lacking. The Sanger Institute's Mohammed Al-Mari and colleagues have just rectified that, saying that the Middle East played such a key role in the human story.
The Middle East is particularly interesting to study human evolution history because it's where humans first expanded out of Africa. It's where hunter-gatherers first transitioned into farmers. It's where the first writing systems developed and where the first civilizations emerged. So all these historical or prehistorical events leave a trace in the genetics of the people who lived there. And we can use modern genomes to reconstruct the history of the region. A whole genome contains information about hundreds of thousands of ancestors. So even a single genome contains a vast amount of information that we could use to study human history.
So you're looking for all those ancestors of the 100 or so people that you've tested?
Yes, exactly. So one of the main findings of our paper is when we compare people from the Levant region, we find that around 10,000 years ago, which is when actually agriculture was developed, we see a huge expansion in population size. We attribute that to the invention of agriculture allowed people to settle down and expand in contrast to hunter-gatherer groups which were much smaller.
Just give me a sense of how you know that a population was growing 10,000 years ago by taking a snapshot of genomes today.
We use something called the coalescent theory. Coalescence just means a time where a mutation is basically first inherited from a common ancestor. So say a mutation that's common between you and me, and it's common in the rest of the population, we probably inherited from a common ancestor. So by studying the density of mutations at specific haplotypes, you can infer the history of a population from genomes of modern populations.
And what about their deep origins? You talked about the fact that this was the first stopping point, as it were, in the out of Africa movement.
Yes, there's been lots of archaeologically documented modern human remains outside Africa that lived around 80,000 years ago or even older. However, the consensus in the field nowadays is humans expanded out of Africa around 50, 60,000 years ago. But there's been interest to see if any of the humans that left Africa previously left any ancestry in modern populations. So what we find in our study is that is not the case. So all of the archaeological remains that we find that are older than 60,000 years in the region, in Arabia, in Levant, they do not seem to have contributed to modern populations. So what we think is they probably went extinct and did not leave any contribution.
The way you say it, it sounds like they never even met, perhaps.
So based on our research, that seems to be the case, that they probably went extinct before they met the population that left Africa around 60,000 years ago.
I guess this is also the time when you had Neanderthals. Did the people in this region meet the Neanderthals?
Yes, so what we find in our study is populations from Arabia actually have lower Neanderthal ancestry compared to Europeans or East Asians or South Asians. It is likely that they have higher ancestry from a population that likely did not interbreed with Neanderthals, that we call basal Eurasian. And because of that, they have lower Neanderthal ancestry compared to Europeans and East Asians. We don't have any Neanderthal remains in Arabia to really understand what was the landscape of Neanderthal movement around that time.
What about any other signs of migration? Can you see other people moving in and out of the region, as it were, leaving a genetic mark?
Yeah, we do see that. So what we find in our paper is during the Bronze Age, there was a movement of population from the Levant south to Arabia and also to Egypt and to East Africa. And that movement of that population overlaps the spread of Semitic languages in the region. So we compared our genetic analysis, the timing of admixture, with linguistic analysis around the diversification of Semitic languages. We find a very strong correlation. So we think that around that time period, a population moved and spread the language.
I mean, that's a very interesting overlap between, shall we say, culture and genetics.
Absolutely. Population movements are also affected by the climate during that time period. So actually, Arabia today is one of the biggest sand deserts in the world. However, 6,000 to 7,000 years ago, Arabia was very wet and very green. But climate change shifted the landscape to the desert that we see today around 6,000 years ago. And populations in Arabia, we find a signal of a very severe population crash around that time.
A collapse in population?
Yeah, it was a population collapse.
I mean, the way you describe it sounds like if it was today, it would be a crisis of some sort.
Possibly, yes. Yeah.
And you can see that again by looking at the timing of the genes.
Exactly. Using the coalescence of habitats, you can see that. And around 4,000 years ago, from archaeology, what we know is there was a very severe aridification event. It's called the 4.2 kiloyear event. And it was a very severe drought. And some historians attribute that drought to the collapse of civilizations at that time period, like in Iraq and Mesopotamia and Egypt. And those populations during that time period, we find a population decrease around that time.
I don't know, how long was this mega drought?
It's thought to maybe last around a century or two. It's nothing like what happened to Arabia, where you have thousands of years of the aridification of the desert. It was a short, severe drought around 4,000 years ago.
But enough to change history and to be recorded in these genes?
Possibly, yes.
Mohammed Al-Mari with a genetic spotlight on a key period in human history and bringing us back to climate impacts. The study was published in the journal Cell. We've put a link to that and to all the other studies we've talked about today on the Science in Action webpage at bbcworldservice.com. But that's it for now from me, Roland Pease, and producer Deborah Cohen. And as Team Crowd Science take over, get ready for action.
Okay, Alex, I'm scared. Are they behind me?
This is Crowd Science from the BBC World Service. I'm Alex Lathbridge, and that's the sound of my fellow presenter, Anand Jagatia, running from zombies.
You've come down in a horde of zombies. They've heard the noise. They're coming.
I don't think I can make it.
Run!
I'm so unfit. I'm going to throw up.
It might not sound like it, but Anand's actually playing a game. He's having fun.
Can I just say that, yes, it was a game, but I'm not really sure that fun is the word I would use to describe it. So the game is called Zombies Run.
Here's one of the people behind it, Adrian Hon, to explain a bit more.
Zombies Run is a running game, and so it's a little bit like a running app that keeps track of your distance, your time as you run outside. But it's also a bit like an audio adventure where we put you into a kind of post-apocalyptic audio landscape as you run, and in order to collect supplies and find survivors and escape zombies, you need to run in the real world. Otherwise the zombies might catch you.
When the zombies appear, the game tracks how fast you run, and you only escape them if you push yourself a little bit harder.
You're not far from the gates now. If you can keep going, we'll send some people with guns out to meet you. Only one zombie is close to reaching you. Just put on a burst of speed now!
You know, it helps people distract themselves, and that only works because you feel invested in the characters and then in the world, and you know, you feel like you're a part of it.
They're following you. The swarm from the car park. They're following you now. Run!
Now, I've been playing's the wrong word, experiencing Zombies Run since 2013, and I found it so engaging that I actually wanted to go out running, which is weird because I hate running. And I'm not alone. Since its creation in 2011, runners have clocked up a staggering 110 million kilometres. Now, Zombies Run isn't a traditional video game where you sit down in front of a screen with a controller, but it is a digital game that has the power to change you in the real world. And that's what this episode of Crowd Science is all about.
The inspiration for this episode came from a question that we got emailed in from someone called Anand, who lives...
Sorry, what? The listener is called Anand. So is that what we're doing now? We're just sending in questions ourselves so we can report on stuff we like you can play video games? Because Alex from Ghana has got a really good question about skydiving over tropical islands, if that's what we're doing.
I mean, that would have been a good idea, but no, this is actually a genuine question from somebody else called Anand, who lives in Switzerland. And he says, Dear Crowd Science, do violent video games cause violence, and why? It's brought up quite regularly in our household, and I'd like to hear some expert opinions.
Other Anand, thanks for writing to us. That's a fantastic question.
There are so many claims and news headlines out there about the potential impact that video games might have on us. That they can make us smarter, that they can potentially be addictive.
So we'll be looking at what scientific evidence has to say about all of those things. But let's start with Other Anand's question. Does playing violent games lead to violence in the real world?
We must stop the glorification of violence in our society. This includes the gruesome and grisly video games that are now commonplace.
So that's former US President Trump in 2019 talking about the link between video games and mass shootings after massacres in Texas and Ohio killed at least 31 people. And over the years, in the wake of tragedies like these, the media and politicians have often claimed a link between the killer's actions and their interest in video games. But concerns about violent games go back a lot further than this. In the 70s, people were worried about an arcade game called Death Race, where you run creatures over in a car. And then in the 90s, it was fighting games like Mortal Kombat, which featured lots of blood and gore as you beat up your opponents. And then there were games like Grand Theft Auto, where players can go out on crime sprees, steal cars, and kill civilians. And most recently, it's first-person shooters based in realistic-looking war zones like Call of Duty. So, is there actually a link between violent video games and violence? Or is gaming just a scapegoat? Like, what's the scientific research?
I'd say that the whole research literature is collapsing in upon itself.
This is Professor Andrew Przybylski from the University of Oxford, where he studies why people play video games and how they might affect us. He's very critical of some of the early research in this field, which claims to show a link between video games and violence or aggression.
You could argue that nobody's really studied video games properly. Often the kinds of things that a scientist does that gets a paper published, that gets headlines, that gets clicks, it's not the same kind of thing that necessarily constitutes, solid science.
What does Andrew mean by a lack of solid science in this field?
Well, some of the work tries to look at the effect of gaming on behaviour in the lab. So you might ask some people to play a violent game that requires you to run around and shoot people. And then you get others to play non-violent games that are suitable for kids. And then you ask both of them afterwards how angry or aggressive they feel.
The main problem with this is that games that have, a mature rating or an 18 and above rating, they're actually very different than games that are made for toddlers for reasons completely unrelated to violence. The fact of the matter is they're a lot harder to play. They're a lot more frustrating. And so there have been quite a number of studies that have showed that actually when they say they feel less happy in the lab when they play a violent video game, what's really happening is that they're getting frustrated.
I can relate to what Andrew is saying. I get pretty annoyed if I am bad at or lose at any game.
You're terrible at Scrabble, we know this, but that's a really good point. And there are experiments that researchers can do to tease out what's actually causing these feelings in people playing video games. I mean, you're a fan of Tetris, right? So what's the aim of Tetris?
Yeah, I love Tetris. So you have these blocks of different shapes and they fall down from the top of the screen and you have to rotate them so they all fit perfectly together and there are no gaps.
Yeah, so researchers have a version of Tetris that's a lot more evil.
There's a version of Tetris called Bastet that instead of kind of dropping Tetris shapes at random, it actually picked the worst possible Tetris pieces for our participants in our lab studies. And we found that it actually made people tremendously, at least in the short term, frustrated. And they told us they felt quite angry after only 10 minutes.
Here's what happened when we got the crowd science team to play it.
I hate those ones.
How's this piece go? No!
I hate it again.
That piece doesn't fit anywhere.
What? Unfair. Ah!
Oh, it's over! That was so rubbish.
I love it so much. And that's the wild thing. A lot of the research doesn't actually control for this. Because once you do it, it seems that frustration or competitiveness can have a much bigger effect on how people feel compared to how much blood or gore is in the game. Tetris has no gore.
But I guess there's something else going on here, which is that those kind of studies, they just look at how people feel, right? So just because theoretically, if I was to get angry because I lost at Scrabble to my girlfriend, theoretically, that doesn't mean that I'm going to act on that anger just because I feel, annoyed.
That's a really good point. So I asked Andrew how you'd go about measuring actual aggressive behavior in the lab.
We would ask you to put your hand in a cold water bath, about 3 degrees Celsius, for 15 seconds. And we would tell you that 15 seconds was picked by the participant before you. I would ask you how much it hurt. Then I'd have you play Tetris or Bastet. And then before you left the lab, I would ask you, hey, how long should the next participant put their hand in cold water for?
That's how you would measure aggression in the lab. It's almost like you're trying to measure how much pain the subject is willing to inflict on another person.
Andrew says that it's a compromise, that it's something that we can measure, but it kind of has limitations and we really don't know if they reflect what people do outside the lab. So with this kind of lab-based research, some studies claim to show a link between violent gaming and aggression, others don't, but it's all subject to the problems that we've discussed, so the evidence isn't very convincing.
What about just looking at people actually in the real world who play video games?
Okay, yeah, there are studies like this too, and they observe large groups of people and see whether people that play violent games are more likely to be aggressive. But with these studies, you can only show a correlation, not a causation, and that's really important. So you can't say that people are aggressive because they play these games. More aggressive people might just prefer more violent games. And even there could be another factor that's driving both of those things. Perhaps some people with difficult home lives are more likely to turn to violent video games to cope. That's one thing. But 2, they're also likely to act out aggressively in school.
Okay, so in that case, it's not the game that's causing the aggressive behaviour, but it's actually their home life that might be driving both things.
Yeah, so bearing those caveats in mind, I'll just give you a few examples. There was a study in 2008 that looked at around 1,600 kids and claimed to show a link, but they didn't control for any of these additional factors apart from gender and prior aggressiveness. There was another study in 2016 which looked at around 1,800 children. In this study, they did try to control for as many factors as possible and only found a weak correlation, which they say is negligible. But Andrew's group published a paper in 2019 which looked at 1,000 British teenagers.
And we found no reliable connection between the presence or absence of violence in those games and their parents' ratings of conduct problems.
So it's kind of like Andrew said at the start, the whole research field is messy. But Anand, and also listener Anand, it would be fair to say that there's currently no clear evidence to support the idea that violent video games cause real-world violence.
Let's move on and look at another kind of claim that's often made about certain kinds of mobile games. So Alex, there's loads of brain training apps out there, and they set you little puzzles or tasks, and they say that these have been designed with the help of science to improve your mental function. So things like attention, memory, multitasking. I'm going to get you to do one of these tasks. It's designed to help you inhibit your reactions. And the claim is that that can help you to control impulses and improve your general mental flexibility.
All right, okay.
You're going to see some words for colours, like red or blue or green, but the words themselves will also be coloured in. Your job is to say out loud the colours of the words, not the words themselves. Does that make sense?
Yeah, let's do this.
3, 2, 1, go.
Okay, it says green, but it's yellow, so I press yellow. Okay, it's yellow, but it's blue, so I press yellow. No, I press blue. Shut up. It's green, but... No, now you're making me miss. Yellow. Shut up. Yellow, now it's red, and it's red, yes, look at that. It's green, but it's blue. No, it's not even blue. There's no...
And stop. Okay, so not bad. You did get quite a few wrong.
Look, I feel as though it would have gone a lot better if you hadn't been making noises, but the idea is that if I use apps with these kinds of puzzles, every day, I can improve my cognitive skills. Now that sounds great, but we need to speak to someone who can tell us if they actually work. Who is this someone? Pete Etchells. Now, he's a professor at Bath Spa University who researches the psychological effects of video games.
There's not much evidence in the world of brain training games that is scientifically valid in my view. So one of the biggest studies in this area was about 10 years ago now. So what they basically did was get people to play them at the start 6 weeks and get a baseline score of how good people are at these particular games. Then get them to play a different set of games that are argued to target the same sorts of skills, and then go back to the original games at the end of the 6 weeks and play them again and see whether you see any improvement. This is what they were looking at, and what they found was that over the 6 weeks, the games that people were training on, they got better at. When they played that original benchmarking game at the end of the 6 weeks, no differences in improvement.
It essentially didn't really do its job. You got better at playing the game that you've been playing for a long time.
Yeah, but that didn't translate into a general improvement in, say, short-term memory skills or problem-solving skills. What we're interested in is something called a transfer effect. So we know that if you play a game for 6 weeks, whatever it is, you'll get better at it. That's literally how humans learn things. The key question is, if you play, say, a game that's supposed to improve your short-term memory, yes, you'll get better at that game, but will you also get better at other things that test your short-term memory? So we didn't see that transfer effect. Now, that doesn't mean that there isn't any beneficial effect of playing video games from a cognitive point of view whatsoever. So there's some evidence to suggest that for older adults, at least, if you use more targeted brain training games, they do get better across the board. 7 or 8 years ago, there was a game called Neuro Racer. You take control of a car. So there's a car going down a winding road, basically, and you've got to keep the car in the middle of the road. Simultaneously, there are some symbols that appear at the top of the screen. You're told at the start of the study, basically, every time you see a green circle, press the space bar and ignore everything else. Now, what they found was that participants get better at the task, but they also showed improvements in quite a wide range of neuroscientific tests of attention and working memory tests. You know, how much information can you keep in your head while you're trying to calculate sums and things like that. They saw improvements in all of those things as well.
So what you're saying is games that are designed specifically and are targeted at older people could lead to general improvements in their cognition. But if I play my generic brain training app that's not designed for me, but I play it every day for 5 minutes while waiting for the bus, it's not going to do much outside of just being good at the app. Like, that's disappointing. Like, the premise behind these apps is really great. Like, I want to be cleverer.
It does sound great, but nothing like that in life is easy. There's no shortcut to improving things like problem-solving abilities and spatial awareness skills and things like that. Sorry.
Alex, when you were growing up, how much did you play video games?
Including weekends, maybe like 48 hours a week.
That's like more than a full-time job, man.
I mean, yeah, look, it sounds like a lot, but remember, I was like 10, so leave me alone, don't judge me.
But it raises an important question, right? How much is too much? Video game addiction is something that's been in the headlines quite a lot over the last few years. Here in the UK, in 2019, Prince Harry actually stepped into this discussion and went as far as to say that the game called Fortnite should be banned and that it was a game that was designed to be addictive. So how bad is the problem of video game addiction?
Look, we should say that billions of people all around the world play video games like Fortnite, including myself. And for the vast majority of us, gaming is a positive thing. But there are people at the other end of the spectrum, and for them, gaming has become a problem.
They have lost control of the amount of gaming they're doing, and the impact is so negative on their lives that they are experiencing adverse consequences because of it.
This is Professor Henrietta Bowden-Jones, doctor and psychiatrist. 2 years ago, she set up the UK's first clinic to treat people who are addicted to video games, what's called gaming disorder.
The priority of gaming leads people frequently to miss school, for example. Young children who would be, trying to escape the house in the middle of the night because the parents had taken the internet. Or, for example, people who are wanting to die and they express this feeling because they can't actually see a life without gaming. And one of the things that I was so very surprised by when I started this clinic was the amount of actually aggression and violence that people are displaying towards their loved ones, their siblings, their families, their pets even, when they are prevented from gaming.
So this disorder can affect people's lives, but the vast majority of people, they play video games with absolutely no problems, and games, they can be like a really positive thing for them.
Absolutely. So, 3/4 of young people are gaming regularly, and we only see a tiny, tiny minority. I'm talking about the extreme end of the spectrum. So there is nothing wrong with someone getting excited about a game and playing a lot because they love the game, as long as they've done their homework and they are not refusing to eat with their family. So there's one has to look at the context. And I like to give the example of, books. Some people like to read for 7 or 8 hours at a weekend. Well, if they decide to do that, it's their decision to do that, just as it is for an ultra runner to run for hours, as long as they don't miss work in order to do it.
Is there a reason why people at the clinic who do have a problem seem to turn to gaming? Like, is there any sort of common thread linking it all?
A lot of the people I see are actually young men mainly, who are living in rather complex life circumstances. For example, we were surprised to see how many had changed neighborhood or changed family circumstances, how many were dealing with quite anxiety-provoking family dynamics, the loss of a parent or the removal of a parent due to a separation or a divorce. So sometimes gaming, helps people to cope with anxious moments in their lives.
So what does the treatment involve?
First of all, you're looking at the individual within the family context, because a lot of the children are saying that they are triggered in terms of their anxiety and their need to escape the family dynamics into the gaming. So we also work with families to reduce the triggers, understand them and reduce them. We look at things like social isolation, trying to reduce that. A lot of these children are very impulsive and they do struggle with regulating their behavior. So we are giving them emotional and behavioral coping skills that allow them to feel stronger in relation to the environment around them.
So it sounds like gaming addiction, gaming disorder can actually be a really serious problem for a small minority of people. And it's really good that a clinic like the one that Henrietta has founded is around to offer them the help that they need.
Yeah, exactly. And that's the part that everyone pretty much agrees on. But what people don't agree on is how many people that this could be affecting, and even more fundamentally, what gaming addiction actually is. Which is interesting because the World Health Organization officially classified gaming disorder as a behavioral problem in 2019. So it's been given an actual definition. But not everyone is happy with it. Pete Etchells, who we heard from earlier, explains that there are two main camps with different views.
So there's one camp that suggests that formally creating a diagnosis criteria, a category of gaming disorder, is a positive thing to do, because there are people who suffer harm from playing video games. And if this becomes a formal thing, then we can help those people. It would mean that it would be easier to start developing treatments for it. It would be easier to develop support networks for it. And the argument there was that you can hopefully reduce the stigma around what is a potentially serious mental health issue, so that people feel more able to talk about it rather than something that they hide away from. So that was one view. The other view was that there's no disagreement with that side of things, but we don't actually know what gaming disorder looks like at the minute. So we don't have a really good list of criteria for diagnosing it. They're based off other sorts of behavioural addictions and substance use addictions. Now, the problem with that is that there might be unique aspects of playing video games and therefore of a gaming addiction disorder that we've just not got hold of yet. We don't really have a clear understanding of. What does that all mean practically? Well, it means that we are either overdiagnosing, so we're kind of saying that too many people in the gaming population show signs of gaming addiction when actually it's a much smaller amount, or we're underdiagnosing, so we're missing the people who do have a serious problem because we've not got an accurate way of testing them and finding them.
Is there any early sense of just how bad the problem might be?
The estimates vary from as low as 0.2% of the population have something that might be considered gaming disorder, all the way up to 46%. Now, that's a huge difference, right? The real number is somewhere in there, but if we get it wrong, then we're going to be causing issues for a lot of people. What I think we need to do almost is go back to basics, and let's just sit down and think really hard about what it is that we're trying to diagnose here and what the criteria might look like.
You have to be really careful, don't you, with issues like this, because obviously if a young person is coming to harm because they play video games too much, they need help. But if billions of people around the world play video games and find them safe, and more than that, enriching, fulfilling, creative, a way to connect with people, all of that stuff, you have to take that into account as well. So you have to be careful, I guess, about creating unnecessary anxiety or a moral panic.
That's exactly it. And both Henrietta and Pete made this point when I chatted to them. We shouldn't solely focus on those extreme cases or sensationalize the issue, especially when we just don't have enough data. And we should remember that people have complicated lives, they have complicated needs. You have to look at the whole context of someone's life rather than simplifying the issue down to video games, good or bad, which is a lazy narrative that does sometimes come up in the media. And that nuance and context is something that we need to recognise if we want to understand why up to 3 billion people around the world play video games. And if you want to do good science to study what the impact of gaming really is.
Alex, for the final bit of the show, there's one last game that I want you to play. And it's something that shows how video games can have the power to help us, actually in quite profound and meaningful ways. The game is called Jokoi, and it's quite simple, but it's also really beautiful, and I think it's quite powerful as well.
I've clicked play. Alright, I'm a sheep? Anand, why am I a sheep? This is nice. It's like a little park, and I can... a little bit of music. I got my 3 sheep friends are just chilling. They're walking around doing their thing. I got a little baby lamb. I got to press left click to feed my lamb a flower and add a melody to the world. Alright, eat a red flower. This funky flower. There are little plants everywhere, and I'm clicking them. As I click them, music comes out. I actually really like this. The music's really cool. I feel really happy. Quite calm and at peace. It feels nice to be able to feed my lamb. Oh, wait, there's an earthquake happening. Why is there an earthquake happening? What's going on? Wait, what? Where's my lamb? Where's my lamb? Lamb?
So what did you make of that? It seemed like you were a bit distraught at the end there.
Yeah, kind of. I had a little baby lamb that I'd sort of made an attachment with, and then the lamb went away. I just got the hang of the controls, and then everything changed.
Well, Jokoi was a game that was created by Sabina Harra, and she's now a lecturer at the game design department of Uppsala University in Sweden. And really, it's a game that allows you to explore bereavement and feelings of grief and coming to terms with death. Now, lots of games use dying or losing a life as a basis for how they work. They're fundamental to the game. But that's not the way that death works in real life at all.
Hello, my name is Sabina Harra.
How are you today? Are you good?
I'm good.
You explore video games in a very different way than a lot of people. Because, lots of video games in some way, shape or form centre around this idea of dying, but they don't really represent death in a way that's human, right?
Most games trivialize the experience of death by making it a repetitive experience that can be relived over and over again, rather than a finite state of losing someone loved that cannot be recovered. So, in a way, video games traditionally don't honor the finality of death. So what death tells the player is that you as an individual have failed.
Yeah, it puts the onus on you as the player, saying it is your fault that these things have happened. And that really doesn't map to life. So more in general, like, how did you become interested in this field, in exploring death and grieving through the medium of video games?
I grew up with video games, and I very early on experienced losses and deaths. And so when I went through my grief as a parent who had lost a child, very small infant, I was interested in finding expressions for my own experiences in video games and repetitively failing to find meaningful examples.
So you decided to design your own game, right? I mean, can you tell me how you designed it?
So what we did was I set up a workshop for women from Austria who had gone through a pregnancy loss. We got together to reflect on the experiences. They, in their imagination, visited the planet where their child lived and described in detail what it felt like to be on these symbolic planets. And through this exercise, we were able to take over some elements into a game world.
Can you explain a little bit about the game? I mean, what did you want people to get out of it when they played it?
When the player moves around, they are followed by a tiny, cute little lamb. And by clicking a flower, the player will feed this lamb. And then the music track of that flower gets added to the background music. That's kind of a metaphor for parents dressing, preparing, and caring for a little baby. And at some random point, an earthquake happens in the game and the baby lamb disappears, and we don't know why. So at this point, the controls are also no longer working. So this is supposed to make players feel this sense of loss and a lack of explanation for this loss as well. This is where the challenging part of the game starts, because players really need to think out of the box and realize that there's a second mouse button on the mouse controller, right? We know that, the right one. Players probably didn't realize that it's there. And that's how we model the existence of self-care, the focus on one's own needs. That is often very much left out when we talk about caring for someone else, and especially in the maternal. But if the players figure out that they can actually not only walk around with the right mouse button, but they can also eat flowers themselves and walk over to the other sheep, the community, we can move on to the next meadow. And then that's where the game ends.
You took me, someone who doesn't have children, who's not experienced anything close to what you've experienced and what you're trying to convey through this game, and you've really pushed me into like even feeling like a semblance of it, like a small part of it. Do you think that video games are a good medium to explore issues of death and grief and mourning?
That's wonderful, first of all. I'm very happy to hear that. I think what makes video games especially appealing to explore death, mortality, and grief is the capacity to work with rituals that you can then change. So you facilitate a particular narrative through action. There's also this potential of creating relationships in this way. How do we interact with each other? How do we express care? What does it feel like to be isolated? How can we model that on the level of interactions, of rituals? There's a lot of space to explore what a particular way of being in the world feels like. And grief and loss are very complex, right? So if we go through a process of love and care before we lose whatever we cared for, and then this loss is final, that is perhaps able to invoke a lot of other set of emotions in players than simply focusing on the question of achievement and performance.
It's actually 10 years since Sabine began researching games and bereavement. And right now, there are lots of games out there, like Jokoi, exploring death and grief in meaningful ways. And that's really important because although we start this show looking at the scientific evidence for how video games might affect us, they also have the power to change us in ways that it's almost impossible to measure, and to reflect on what it is to be human. That's it for this edition of Crowd Science from the BBC World Service.
Today's episode was inspired by a question from Anand in Switzerland.
It was presented by me, Alex Lathbridge.
And it was produced by me, Anand Jagatia.
If you have a question for us, you can email it to crowdscience@bbc.co.uk.
Thanks for listening. Bye.
Last year, the BBC World Service made a podcast called World Wise Web.
I just remember having my mind blown.
In the podcast, teenagers like me spent time with the people who invented the tech that has shaped our lives.
We believed someday everybody would have a cell phone.
This year, World Wise Web won a British Podcast Award.
You have conducted probably one of the greatest interviews I've ever had.
To find out why the judges liked it so much...
Wow, okay, we are in a new world.
Search for World Wise Web wherever you get your podcasts.
I have no doubt you'll do something amazing.